Okay, so chapter 1, section 1.8 is all about SOHCAHTOA, right triangles. So let me just recap with you SOHCAHTOA again, just in case you forgot. So we have SOH, we have CAH, we have TOA. So means that sine equals the opposite over the hypotenuse. O over the H. OH, so SOH. That's our first one. Ca is cosine equals the adjacent side over the hypotenuse. So that's AH. That's why those two are always going to be less than 1, because the hypotenuse is always on the bottom of those two. Hypotenuse is your biggest number in the triangle. And tan is TOA. Tan is your opposite side over your adjacent side. So we covered this back in chapter 9 of geometry, but just wanting to recap with you, just because this is the section that's going to use applications to that. So there it is. I'll keep it up there. It'll be there for you. Let's look at number 1 here. Example 1 is asking us to solve the triangle. So that means we need all 3 sides, all 3 angles. The nice thing is they gave us that C is a right angle because it's a right triangle. So solve the right triangle, that means C is 90. You've got another angle that's 34.2. So this angle up here, A and B together have to equal 90, because you've already got one angle that's 90. So 90 and 90 is 180. So we're going to just take 90 and minus the 34.2. You will get 55.8 degrees. So this angle right in there, 55.8. So that's one piece solved. I'm going to box that up, show you that that's one piece done. Next, we need to find little a, and I would use the angle they gave me. In case I made a mistake, I don't want to use an angle I came up with in case it's wrong. So I would use the one they gave me. That's the opposite side of it would be little a. The adjacent side of it is my little b, and my hypotenuse is always across from the right angle. That's my C. So if I was going to go alphabetically, I would do A first, little a first, which is the opposite and adjacent, so it's TOA. It would be tan of 34.2 equals the opposite side, little a, over the adjacent side, which is 19.4. So since the a is on the top, you are going to multiply on both sides. So multiply by 19.4. So make sure your calculator is now in degree mode, because we have been switching them back and forth. So always double check, since we're using degrees, you got to use degree mode. 19.4 times tan 34.2. You're going to end up with 13.18. That is your little a. That's to the nearest hundredth. And then your little b, no, we got little b, we need a little c now. So if I'm using the 34.2 still, then I need the a and the h, so I need cosine. Cosine is cos, C-A-H, 34.2, and you're going to do the adjacent 19.4 over the little c. Do you remember what happens when the little c is at the bottom? What do we do to solve that one? You are going to switch the cosine and the little c, because if you cross multiply, you'd be multiplying those anyways. So you're going to put little c equals 19.4 divided by the cosine of 34.2. Hopefully this is all starting to come back. Remember what we talked about before. So let's divide those. 19.4 divided by cosine 34.2. You should end up with 23.46. And that would be your last piece. That's your little c. So solving right triangles, just finding the sides, angles, use SOHCAHTOA. If it's a right triangle, you're using SOHCAHTOA. Example 2 is a word problem, and sometimes it's better to have a word problem because it's not asking you to find out all the pieces in a word problem. Usually in a word problem, they only want one piece. They want you to solve for one part of it, like this one. So we've got a fire truck. And safety regulation states that the maximum angle of elevation for a rescue ladder, now remember, angle of elevation is from horizontal. So from horizontal going upwards on a ladder, the maximum angle of a ladder is 72 degrees. Can't go higher than that because then that could tip over depending on its weight distribution. So can't be higher than 72 degrees. They want to know if that's the case, then how far up this building can the ladder reach? Is what they want to know. Keeping in mind that the ladder is 4 feet off the ground already when it starts because it's on top of the truck. The truck's 4 feet off the ground. Might even be more than that, but that's what they got in this picture. So let's see if we can figure out the little a, which is our opposite side. And we have the hypotenuse is the 110. So OH, I'm thinking sine, SOH. Sine of 72 is equaling the opposite side over the hypotenuse. So I'm going to multiply both sides by 110. So we're looking at 110 times sine 72. 104.6 feet. Now, if you put that in, you would get this problem wrong because that's only A. That 104.6 is just this little A right there. You still have 4 feet at the bottom that you need to add on because it's off the ground. So you're going to add 4 feet. So you need to get 108.6 feet is its total height off the ground. So that would be our total. Total height, 108.6 feet. Like I said, sometimes the word problems are nicer because they only want one piece of it. It's a little quicker. Now, next example is another good one. You're going to need to know how to use multiple right triangles to solve a problem. In this one, you've got a building, and on top of the building, you've got a smokestack. So buildings have things on top of them, antennas, things like that, but you might have to find the height of an antenna or whatever. So in this case, they have a smokestack on top of the building. So it says at a point 200 feet from the base. So we could stop there and put in our base is 200 feet. So at a point 200 feet from the base of the building, where the angle of elevation to the bottom of a smokestack is 35 degrees. So that right triangle gets us to the top of the building, which is the bottom of the smokestack. That's this bottom right triangle here. Okay, we have little a as my opposite side. And I have the 200 feet as my adjacent side. But that's not what it's asking for. Let's keep going. Whereas the angle of elevation to the top of the smokestack is 53 degrees. So from the bottom going all the way up to the top where the smokestack is would be a 53 degree angle. So you're looking at this bigger right triangle out here, right? Which probably would be better just to keep it right next to the building where these guys are, but that's our other right triangle. So you've got a big right triangle, the whole thing. We'll call it this one right here. Okay, the whole thing, and then you've got the little right triangle, which has your A. I'm going to call this whole thing X because I can't get the smokestack right now. It's not a right triangle. I don't have enough information for law of sines or cosines right now. So I need to find X. I need to find X, and I need to find A. And if I subtract those two, whatever's left over is your S, your smokestack. So if I wanted to find my entire amount first, I would need the 53 degree angle, and I would use tan, TOA, T-O-A. 53 would give me the x over 200. So if I multiply both sides by 200, that'll give me the entire height of the whole thing. So 200 times tan of 53, you get 265.4 feet. That's the entire height. That's this back height right here, 265.4 feet. Now, if I go to my other right triangle, which has little a in it, I can find out the part of the big triangle and just subtract it to see what s is going to be. So I want to get little a now, so I'm going to do tan of the smaller angle, 35, because that's in the smaller right triangle, this little right angle right here. And then you want the opposite a over the 200 this time. Still 200. Adjacent doesn't change. So we're going to multiply by 200. So you're going to get 200 times and hit tan of 35. Should get 140.04, so I'm going to use 140. 140 feet. So that means that the whole thing was 265.4. This piece, just from there to there, is 140. So I'm going to put a 140 in here. Is my opposite side. From here to here was 140. So to get that smokestack, you just subtract the 140 out of the whole thing, the 265. So little s is going to be 265.4 minus the 140. So little s is going to be 125.4 feet. So that would be the smokestack by itself. So we just use two right triangles and subtract. Subtract the smaller one from the bigger one, you get what's left over for the other triangle. So that was the third one. Now the fourth one is probably your easiest one. You don't have to write down all the words. I would get a little diagram of it or whatever. This is kind of like a cross section of the pool, of a swimming pool. So like if you'd had put plexiglass in front, all of this would be water in here. Okay, that'd be all water. You'd be able to see the water and see the shape of it. So you'd be able to see that at the shallow end, it goes down 1.3 meters, about 4 feet. And then it starts to go down at an angle down to the deep end. So you'd be able to see that if you swam down to the deep end, you come all the way down, it would be down 4 meters, which is over 12 feet deep. So that's the angle. They want to know what is the angle of depression from the horizontal line. If you'd stayed straight across shallow end, how many degrees did you descend? So that's the angle of depression. And the cool thing is they gave you the 20 meters, which is just this top side, and then they gave you this 2.7, which is your opposite side. So you need O and A, you need TOA, but you need an angle, so it's inverse. Inverse tan, and you're going to do 2.7 over 20. So inverse tan, 2.7 divided by 20. And since it's a smaller number, I'll go to the nearest hundredths. So 7.69 degrees would be your best answer for x to the nearest hundredth. So it looked like they gave you a lot of stuff in there, but really they're just looking for an angle. So you just need to do an inverse trig function. That's it. Now the last example is the trickiest one, probably all of them. You're going to need to learn how to do navigation. Okay, so let's check it out. They're in a boat. Let me set up the scenario for you. So it says a ship leaves port at noon and heads due west. Okay, hopefully you know what due west means. Okay, due west means straight west. So it's going that direction from A, straight across, west. 20 knots per hour. That's how they measure boats, nautical miles per hour. So you're going for 2 hours in that direction. Okay, and then you're going to turn at 2 hours, so that's at 2 o'clock because you started at noon. You're going to be at B, and then you're going to turn for another hour and go 20 more nautical miles to where you are at D. Okay, so you started at A, you went 1 hour, which is 20, and you went another hour, another 20. So you went 40 nautical miles to start. Then you got to a point B and you turned, and it says you turned north 54 degrees west. Now, what does that mean? That's what you're going to have to know. You're going to have to know how to do that kind of navigation. What does north 54 degrees west mean? You always start with north-south. You measure from north-south. Okay, so that's your start. So if I'm starting at north over here, okay, you see N right here. If I'm starting at north, this is the direction you're going. So you're going in the west direction. And you're going 54 degrees in that west direction. So from the north, you're going 54 degrees towards the west. That's what that means, north 54 degrees west. Now you know how to remember that north, east, south, and west, right? Never eat soggy waffles. Just so you remember that, so you know where they go. I don't want you to forget that because you're going to need that. So we're trying to find now, so it says it gets to the point D at 3 o'clock. And let's say that they hang out there and they do what they're going to do, fish or whatever, and then they want to come home. And they want to come straight home. So they want to know how far are they going to have to go to get straight home, and what direction are they going to need to put in on their computer to get them in that right place to get home. Okay, so what's the distance home? What's their direction home? Got to find the distance first. Well, technically we don't have to, but it'll be easier to find the distance first. So let's find C. Now you could almost use law of sines or cosines to get C, because you could figure out this angle right here. You do have this side right here, and you do have this bottom side. So technically you could use law of cosines. That's not fun. And we haven't learned law of cosines in the trig book yet. So I would stay with SOHCAHTOA. And so what I would do instead of that is find the little b and the little d first for this right triangle over here on the side. So let's look for little b and little d. I know that this is going to be 36 degrees. Okay, because 54 and 36 is 90, and this is a 90-degree angle. North to west is 90 degrees. So I've got my opposite side right here, 36 degrees. This would be my OPP. And then I've got my adjacent side down here. And then across from the right angle, this is my hypotenuse. So I'm going to do OH. I'm going to do SOH. So I'm going to do sine of 36 equals the opposite side B over 20. And I'm just going to multiply both sides by 20 real quick just to get little b. So 20 times sine of 36. You get 11.76 nautical miles, NM. Okay, then I'm going to find little d, which is just cosine of the same thing. Still 36, still 20 is a hypotenuse. So cosine of 36 is going to equal d over 20. Instead of b over 20, it's d over 20. D is your adjacent. So multiply by 20 on both sides. You need little d. You're going to get 20 times cosine 36. That's going to give you 16.18 nautical miles. So you've got your other two pieces that you need. You got 11.76 for little b. Okay, so this is 11.76. And this little d is 16.18. So now look at the big right triangle, the whole thing, from A to D to C, ADC, the big triangle. You now have this side And you also have this bottom side now. You've got the whole thing. You've got 40 plus 16.18. You've got 56.18 for the whole bottom. In every right triangle, Pythagorean theorem works. If you've got two sides, you could simply do Pythagorean theorem since we don't have any of the angles. So I could do 11.76 squared plus 56.18 squared equals c squared. I can put that straight in this calculator. 11.76 x squared button plus 56.18 x squared button, and hit equals. I get 3294.49 equals c squared, and you square root both sides. So you're going to do the square root of 3294.49. 56.4 when you round it off for little c. No, 57.4 nautical miles. There's your distance. That's one answer of your two. That's one solution of your two that you're looking for. The last part of it is how are they going to get home? They went northwest to get out there. What do you think they need to get home? Opposite. Southeast. You went northwest, you got to come back southeast, right? If you went northwest, you got to turn around and come back. So we know they're going to be coming southeast. So I know it's going to start with south, some degrees towards the east. I just got to find the degrees. So I go to the boat. From the south, how many degrees towards the east? Because I'm going from south towards east. How many degrees is that going to be? So I need that inside angle. I could use inverse sine if I wanted to. Inverse sine, since I want an angle, and my opposite of this angle is the 56.18. The hypotenuse is 57.4. That will get me the angle. It'll be an approximate, it'll be rounded, but that's okay. Inverse sine 56.18 divided by 57.4. And you get 78.2 degrees when you round it off. So if you put in that degree angle for your navigation home, that will take you straight back to port. So from the south, they're going 78.2 degrees toward east. That will get them home. They won't have to go as far. Traveling, they went 40 plus 20. They went 60. They're only coming home 57.4 kilometers. Nautical miles. So that's a little less because they are coming straight home, exactly straight. All right, that's it for 1-8.